this is a demo for if statements, and I'm going to use a very simple if statement first here. I'm going to declare double grade, let's say, is equal to 90 point, let's say here 90 point or 93.5. And then what I will do is that I will say if grade is greater than 90, system.out.println letter grade A. All right. So if I compile and run, it's going to execute letter grade A because that condition is met. So if the condition is met, it's going to execute this part. Notice here how Java highlights this as the scope of the if statement with that gray region. Now, another thing you need to notice is that there is no semicolon at the end of the condition of the if statement, right? And what Java does is that it uses this semicolon as the end of the if statement. So I could actually write this statement something like this, and that would be functionally equal to what we just wrote before. However, as we mentioned before, programming style would require you to include a new line with an indentation, so this way it's easier to read. Now, the other thing that we want to do is to say, okay, what if we want to execute or say congratulations, all right? So here is what you can do. You could go and say system.out.println congratulations. All right. Now, is it going to compile? Is it going to run? Yes, it's going to print it. But this is a very important concept here that you need to understand. Congratulations executed and printed not as part of the if statement. It's not because that condition was met. It's because it comes after the if statement. So if I try to make an auto layout in BlueJ, notice what would happen for the layout. Java doesn't treat this statement as part of the if statement. All right, so this print method here, println method, is not part of the if statement. You see the scope? So in this case, what happens that this will execute and it's going to print, but we do not call it conditionally executed, right? Because here's the thing. What if I get a grade less than 90? So let's say 80. All right. Congratulations still will run, even though letter grade A did not run. Now, letter grade A did not run and print because it's a conditionally executed statement and the condition was not met, and that's why it's not going to print. However, this part is not conditionally executed statement. To make it conditionally executed statement, I will need to enclose both of them into curly braces to define the scope of the if statement. So this way I'm extending the scope of the if statement. See how the gray area or region extended? This means the if statement now spans all of this part. Now I will start to work with the classification of the aircraft. So I'm going to create a new class. Let's call it is supersonic. All right. So I will start, because I plan to prompt the user for the fly speed, I'm going to import my scanner class. So import java.util.scanner. And then I'm going to create my application as a main method here. So public static void main string args, and then I have my main method here ready. So I will start by defining the speed of sound. I'm going to define it as a constant using the final keyword. So I'm going to say final double speed, all uppercase, is equal to 344. And then I'm going to declare or create a scanner object. KB is equal to new scanner and link it to system.n. And then I am going to create a system.out.println to prompt the user for the input, which is the speed. So enter the fly speed. All right. So I will store this value in fly speed, which is double. So fly speed is equal to kb dot next double. Then double mac is equal to fly speed divided by speed, the constant. Notice here that even if I define mac to be double and these two were ints, it's going to store it as, it will do the calculation as int and then store it as a double. However, since I declared both of them to be double, now I know that this division is going to give me a double division, and this is going to be stored in a double variable, which should make the mac number very accurate. All right, so now that I have my mac number, I can now do whatever decision that I want. So I could go and say, for example, ask if mac is greater than 1. This means it's supersonic, and I'm going to print that out. So here I'm going to say supersonic. All right. Compile. Let's run it. So if I enter fly speed that is below 344, this 250, and we know it's 0.70 something. So here it's not going to print anything because it's not supersonic. It's not greater than 1. This is not going to execute, so nothing will be printed, right? However, if I give the value above 344, let's say 350, so it's supersonic. All right. Now remember that if I wanted to print the mac number, system.out.print line, and then here I'm going to print mac. This is the example we had in the video. Notice here how auto layout kicked that supersonic out of the scope of the if statement. It included this as the scope. So if you have an if statement without curly braces, the only single line that comes after it is the part of the if statement. Anything else is outside that if statement. All right. So if I want both of them to be conditionally executed, if the if condition is satisfied, in this case, I need to enclose both of them in curly braces. Run. And then if I enter 350, it's going to print 1.017, which is supersonic because it's beyond 1. Now I could stack a couple of these. So for example, here I could say for here if mac is greater than 5, then in this case it's hypersonic. So, hypersonic. All right. Now I can repeat this here and say if it's greater than 1 and mac is less than or equal to 5, then in this case it's actually supersonic, right? Then I can check if mac is equal to 1 by equal, then in this case we say that this is a transonic, right? And finally, if mac is less than 1, in this case system.out.print line, we will say that this is subsonic. So notice here we have stacked if statements. Some of them, even though it's a single line, I could still include curly braces, which is perfectly fine. And actually it's a better practice because it makes it easier to read. All right. So if I run this, so 250 is subsonic. 344 is transonic because it's equal to 1. 350 supersonic. Let's enter something crazy that is still supersonic. Oh, all right. So let's do hypersonic. There we go. So it's classifying this properly. All right, so it's telling me, and notice here I use the AND operator to include that it's greater than 1 and less than or equal to 5. Notice here that if I said just greater than 1, that can cause problems, because greater than 5 would be hypersonic, which is fine, right? So let's say I entered the 2500 and it tells me your plane is hypersonic. Then it goes to the if condition here and checks, is it greater than 1, which is going to be yes. So it's going to tell me, oh no, it's supersonic. But that's not accurate because it should be hypersonic. All right, so to understand what I'm saying here is that if I close this here and comment the rest of this condition, all right, like this, compile and run, right? And I enter 2500. It's going to tell me it's hypersonic, it's supersonic. That's not correct. So that's why we had to define the scope or the range of what defines supersonic, which is greater than 1, less than or equal to 5. All right, so you have to be very careful with this. When you put your conditions, it has to be very accurate and correct.